qualities. All right. And today I found a grid on this little screen here. Okay. Let's just talk a little bit about what a linear inequality is. All right. There we go. Not what I wanted. There we go. All right. So, a very simple example of a linear inequality would be on a graph, x is greater than 0, okay, which means that, equal to, all the x's on here are greater than 0, okay? But not only are the x's on this line greater than 0, but all the x coordinates that are here are greater than 0. And all the ones that are down here are greater than 0. So when you talk about x being greater than 0 as far as a linear equality, we're talking about everything that's to the right of that y-axis. All this stuff is x is greater than 0. Okay? That's what a linear inequality looks like. All this stuff in here. So if we say, okay, what if we have x is greater than 0 and y is greater than 0, and I'm going to change the color here to like a light blue kind of. Okay, so now we're talking about all this stuff. Okay, all this in here, because all this is greater than or equal to 0. If we talk about the overlap of these two things, then we're talking about this real mixture of blue and gray. Okay, that's what we're going to start looking at, is just graphing some linear inequalities, all right, and shading regions of where they are. Okay, so let's start doing that. Let's start off with that. Let me give you a little example. Suppose we have y is greater than or equal to x plus 1. So we'll just start off with something like this. All right, so I'm going to take my little graph here, make a graph out of this. I don't want that. Red. I didn't want it to do that. There. Like that. Okay. And then like this. Okay. So I know it's probably hard for you to see the little there's a little grid here. Okay, so we're going to graph y is greater than or equal to x plus 1. So what's the slope?
1.
Slope is 1. Good. What's the y-intercept?
1.
1. So I'm going to go up to 1, put a dot there, and then rise over run. So how much do I go up? I'm going to go up 1 and over 1. Okay, there's my line right there. Okay. Now, here's the problem I have to figure out, though. I need to know which way I'm going to shade above or below that line. Okay. Now, I'm going to show you two ways of doing it. All right. And then you can decide the way you like. Once again, you can decide that. Okay. So, the first way is called the checkpoint way. And this is the way that's in your book. All right. Here, it's supposed to be like a green. Sorry. Checkpoint way. Okay. The checkpoint way says you pick a point on either side of this line. Doesn't matter which side you pick. You just pick a side. You just pick a point. Usually, the easiest point to pick is 0, 0. 0, 0 is on this side of the line. So I'm going to pick that point. And now what I'm going to do is I'm going to substitute it into this equation and see what happens. 0, 0. 0, and this would be 1. So, is 0 greater than or equal to 1?
No.
Nope.
No
So that, no, not no solution. So that means that the answers to all the points is on the other side of the line. So that's the side you would shade. Okay? That's called the checkpoint method. You pick a point on one side of the line, you plug it in, Check to see if it's true or false. If it's true, you shade that side. If it's false, you shade the other side. Okay? That's called the checkpoint way. The other way. So now let's do it the other way. So I'm going to draw my line here. Draw this going across here. Okay, now I'm going to go ahead and do the same thing that I just had. Let's see, what was that equation? Y equals x plus 1. Y is greater than or equal to x plus 1. 1, 1, 1, 1, 1. There's my line right there. Okay. The other way to do it is to just kind of look at it and be able to read it. All right. So, what does this say? Y is greater than or equal to x plus 1. So, here's my line. Would I shade above the line or below the line if y is greater? Which way would we shade? Good. There's the answer. Okay, there's the answer. All you got to do is be able to understand what that means. Okay, so this said y is greater. So I asked myself, well, here's my line. Would I shade above it or would I shade below it? Well, since y's got to be greater, then I'm going to have to shade above. Greater would be associated with above. Okay, so that's how you do it. You can use the checkpoint way or you can do the other way. Doesn't make any difference. You got to pick the way you like. Let's try some more. Let's go with y is less than 1/2 x minus 2. Okay, so we're going to graph this one. And graph it here. I'm going to put this down here. Okay, so my equation is y is less than x minus 1/2 x minus 2. I go down to the y-intercept, which is -2. What's my rise? 1/2. There's my slope. Now, I have to be careful on this one because this is a less than. Okay? And remember when we did these before, we had the open dots and the solid dots? Kind of remember that maybe?
Yeah.
Okay? This is the same idea, except instead of a solid dot, you're going to have a solid line if it's equal. So if you have this type of situation, you're going to have a solid line. If you have this type of information, you're going to have a dashed line. Okay, so this is going to be a dashed line like that. All right, and now I have to decide which way I'm going to shade. So if I'm a checkpoint person, then I'm going to put a checkpoint in there. Which point would I pick for that? Yeah, 0, 0 would be the great checkpoint. Okay, so let's see, I have y equals 1/2 x minus 2. 0 here, 0 here. Yeah, you're right, Les, thank you. So I have 0 is less than 1/2 times 0. What's 1/2 times 0?
0 would be -2 then.
So just want to make sure I did it right. Is 0 less than -2? No. So that means I wouldn't shade up here because that's where 0, 0 is. I better shade down here. Okay. If I do it the other way, I would just read this. Y is less than 1/2. So which way would you shade, above or below the line? If it's less than, there it is. Okay. There it is. Now you really have to be careful because when you're doing all these things on Sunday night, and you're drawing these lines, and all of a sudden they throw a dashed one in there. You got to be careful with that because that will happen. Okay, if that happens and you go back and you go, oh, I forgot, you can just tell me that this was supposed to be dashed. Just say dashed, okay, because I know what you meant there. All right, so you kind of got to be careful. All these we're graphing them too. Okay, all these are being graphed. So let's try one like this now. Let's do this. 3y greater than 12. Okay, so let's say we have one like this. Okay, we're going to have to graph it to get the answer. Gosh, I thought I told it to do it this one. There we go. Okay, so can we graph this like it is? What do we got to do with it first? So do what? You can get y by itself. Okay? That's one way of graphing it. And I've seen some people do it different ways. What's another way to graph it? I just want to cover all of it. Reeves looking at me like, what are you talking about, right? Remember, you could do x and y intercepts, right? And there's people that are doing this on their quizzes. They're finding the x and y intercepts, plotting those points, graph a line. You can do it that way. That's not a big deal. Okay? And you could also make a t-chart on it, right? That's what we first did in the very beginning. Okay? All right? I don't really care how you graph it, because all the questions on the test, on the quizzes, so far are said graph it. It doesn't matter to me how you graph it. I like to put it in y-intercept form, so I'm going to go move this over here. Okay, that's kind of what I like to do. Now, what do I have to do to finish it? Because it's not in that form yet. What do we got to do? Yeah, we got to divide by 3, right? Divide by 3, divide by 3. So here we go. Y is greater than negative 2x over 3 plus 4. You with me on that?
No, I thought you had to flip the symbol if you multiply it on greater or less than equations.
When do we have to flip the sign?
Yeah. Oh. Alright.
It's only if it's negative. Well, I was going to do one of those too. So, all right. So here we go. So y-intercept is how much? 1, 2, 3, 4. And the slope? Down 2 over 3. Down 2, 1, 2, 3. There it is. Dashed or solid line? Dashed. Again, because it's less, not equals to, so it's going to be dashed. Okay, something like that. All right. Okay. Again, we can pick a point, do our checkpoint, or you can just read it and look at it. However you want to do it. So I'm going to pick 0, 0 as my checkpoint. Let's see. So 0 goes there. Negative 2/3 times 0 there. Plus 4. Basically, this is going to be 0 is greater than true or false? False. So that means we're shading. Now 0, 0 is here, and it's false. So that means we got to shade on the top because it's not there. Okay. All right. If I'm reading this, y has got to be greater. So would I shade above or below the line? Y has got to be greater. Which way are we shading? Above. Okay. It's above. All right. That's all there is to these, is just you're just taking the lines and you are just graphing them and shading them. All right. That's all we're doing. Let's try let's try this one. And like this. And like this. That's not too bad. Okay, so we'll try another one. How about let's do negative 1x minus 2y is greater than or equal to this time, and we'll go with 4. All right, so we got to graph this. All right, I can find x-intercept, y-intercept, graph it, t-chart. I'm going to put this in slope-intercept form because that's the way I'm going to like to do it. I need to put plus there. X plus 4. I'm adding x to both sides here. Adding x. Okay. But I have a negative 2, so I have to divide it all. So here's the example Hunter was asking about. So what's going to happen to this? Now you got to flip it. Because you're dividing by a negative. Okay. X over negative 2 minus 2. And so I just take this in there. this I'm leaving alone. All right, so here we go. We're ready to go. What is my slope? What's the slope? 1 over negative 2, because there's actually a 1x here. Okay, what's the y-intercept? Negative 2. I'm going to put my dot there. Let's see, you guys said, so I'm going to rise how much? Up 1 over 2, but it's back 2 because it's got to be that way. Solid line or dashed line? Okay. This time I'm going to go backwards with it. Y is less than, so would I shade above or below the line? Okay, again, if I pick 0, 0 to put in my checkpoint, I'm going to get that. Is 0 less than or equal to negative 2? Is 0 less than negative 2? No. So, see, it just backs it up. Okay. No, because, well, no, we put 0, 0 in there, and this was a false, right? Okay. Now, you don't have to do the, if you're just reading it and shading it, don't do the checkpoint, because you already know. Okay? You only do the checkpoint way if that's the only way you understand it. All right, you can pick either. I don't really care which way you do it. You just got to find the one that you understand. So let's try another one. I want to try one like this, where we have a little different situation. Okay. So they're going to have some that are going to be like y is less than 1/3 x. Okay, so we'll do one like this. What is the y-intercept? 0. And what is the slope from here? 1/3. So I'm going to go 1 over 3. Solid or dashed? Okay, so I got a dashed line here. Okay. Now, when I do a checkpoint, what point can I use? Can I use 0, 0? No, because it's on the line. So when you use a checkpoint in this situation, you can't use 0, 0 because it's on the line. You need one side or the other. So you'd have to pick another point. Right? I could pick this one, I guess. Let's see, that's 0, 1. So 1 there, 1/3, 0 there, 1. So I write down I use 0, 1 here so you guys know. Okay. 0. Is 1 less than 0? False. So which way do we shade? Got to shade below because I picked that point. Okay. All right. Notice that's consistent with what this says. Y is less than 1/3. I'm going to shade below. All right. Going to shade below. And that's that. That's those. So that's all the stuff with linear inequalities. Any questions on that? Those ones that we did there? You know, really the toughest thing is just one thing is to remember you're graphing them. Okay, like that. And just getting the dashed lines and the solid lines figured out. All right, let's look at page 276. Can you do that, 276? Take a look at that. I want to look at number 2. Says 2x minus y is less than 3. 0, 0. 3, 0. -4. -15. There's that. There's that. Okay. Question is, determine whether each ordered pair is a solution of the given inequality. So we want to know if any of these are solutions to that. Okay. Any ideas on how we can figure that out? Do what? Plug them in. Sure. Let's put 0 there, 0 there. 2 times 0 minus 0 less than 3. This is going to be 0 less than 3. Yes, or is that true or false? True. So that would be a yes, that is a solution. Okay, so I just put it in there, check to see if it worked, and it did, so I say, okay, that one is. All right, let's try this one. So now we're going to go 3, 0. 2 times 3 minus 0 less than 3. 6 less than 3. 6 is less than 3, we're saying false. So that one's not one. Okay? So I'm just taking these points, substituting them in, checking to see if it works. Let's see, 2x minus y less than 3. 4 is going to go there. 15 is going to go there. Is it 15? I guess it is. So I'm going to get 2 times negative 4 minus negative 15 less than 3. Negative 8 plus 15 less than 3. 7's less than 3. 7 less than 3? False. Okay, so the only solution I have is 0, 0. Rest of them didn't work. Okay, so all you got to do on those ones, you're just substituting points in, figuring out if they work or not. Okay, the rest of the time you're graphing them, finding out, graphing them, and then just checking them or shading them. Okay. That's pretty much it. Any questions on any of the stuff that we did right there on 3.6? He says no. Nick says no. All right. So let's do this. Let's move on to our first supplement thing here. It's not 3.3, but it's 3.4. And it's on page S9 in the very back. S9. You should be able to just do these actually pretty much on your own. Okay. It says, is everybody there? Okay. For the following equation, state what the slope and y-intercept are, then use the slope and y-intercept to graph the solutions to the equation in the space provided. Label the label the y-intercept and label the graph with its corresponding equation. You'll need to choose an appropriate scale, la-di-da. Okay, so our first one, y equals 6x plus 30. Okay, gives me a little grid. I guess you have to make your own grid. So it's kind of hard to choose a scale here. I'm just going to go like this. Kind of go in the middle. Okay. All right, so we're going to graph these. Dang it. 6x plus 30. What's the y-intercept? 30. Now, obviously, I'm not going to fit 30 on here, so I'm going to have to go by something. What should we go by? 5. 5, 10, 15, 20, 25, 30. Okay, there's 30 there. All right. If I go by 5s here, what has to happen on the x-axis? You really need to go by 5s, or else it's going to distort the graph. Okay, so you want to go by 5s here too. 10, 20. All right. So here's my, there's my y-intercept. Okay. What's the slope?
Up 6 or what?
Okay. So now I have to go up 6 and over 1. Okay. So I might run out of room doing this because up 6 is going to be way up here. All right. So how could we modify it so that we don't go up 6? Could we go down 6? we could go down 6 and to the other side, right? Nice job. So I'm going to go down 1, 2, 3, 4, 5, 6, back 1. I still get that positive looking line. Okay, so what I did is I went down 6, back 1. Okay, I ran out of room, so that's what I did. And it's the same line. It doesn't make any difference. Okay. Notice that in actuality, I don't know, I'm surprised nobody said anything. Well, you didn't really go down 6, you went down 30, right? But because you're going 30 and 5, that is the same as 6 and 1. Okay? So if you go down 6 and 1, that doesn't necessarily mean you have to go 6, 1 units. You can go any ratio, and it's still going to be the same thing. Because you're keeping the slope the same. All right? So you could have went down 12 and 2 if you want to, so that's going to be the same thing. Right? That's why we did that. Okay, well, what else we got to do here? Label the y-intercept. Okay, y-intercept is 30. There it is. Use slope y-intercept. We did. Label x, label graph. Of course, I did. Got a scale. Did. It's done. That one's done. That one was A. Okay, let's do B. Dang it. Alright, here we go. Gonna do B. Okay, y equals negative 50x plus 250. 250. Y-intercept. What's the y-intercept? 250. Okay, we're definitely scaling this one. What do you want to go by? 50s. 50, 100, 150, 200. 250, 300. All right. So if I go by hundreds, do I need to go by hundreds here? It's good that you do, or else your graph gets distorted. So it'd be 100. You don't have to, but it's a good idea. 200 there. Okay. This there. Put those there. Whew. All right. What's the y-intercept? 250. Put a mark there. What's my slope? Over 1. Okay, so I can't really go down. I can go down 50 here. If I go down 50 here, that's going to put me to right there. But if I go over 1 or back 1, man, that's just a tiny, 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 tiny bit, right? Okay. Okay, so if I'm going to use the exact units on here, which are fine, if I'm going to go back down 50, then that would be 50 and then over 1. It's going to be hard for me to graph, okay? So let's try going down a little bit more. So if we go down to 100, then how much will I have to go here to make it the same as 50 and 1? 2. Still not very good. I mean, I still have 50 marks there. All right, so if I go down to, let's see, another 50, that's 150, right? That'd be over 3. So you see the dilemma we have here. It's not very good. So let's go down as far as we can. If we go down to 250, which is take me all the way back down to here, how much will I have to go over to get the same ratio? 5. Okay. Not ideal, but a little bit better. I'm going to put a little mark there, and then I'm going to draw this in. Okay. It's a very, very steep line. All right. Okay. Now, what you could have done, if you say, hey, I don't really like that, then we could have changed the scale on the x-axis, so we go by 1s, and then it would have worked. The only thing is, it just distorts your graph. All right. So what we could have done is we could have went like this, and we could have said, okay, I'm going to go here and here. And when I graph it this time, I'm going to go by 50s on this one. But I'm going to go to 1s on here. Okay, so here's 200, here's 300. So there's 250 I want to go down 50 and back 1, and that's what it would have looked like. Easier to graph, but it's distorted. Okay, this looks flatter than this does, okay? But there's still the right answer. You just scale it the way you want. All right, let's do the next one. Let's see, what do we got next? 1/12 and 4. Okay, here we go. 1/12 and 4. Like that. This guy. Y equals 1/12 x minus 4. Okay. Oh, I don't know if I wrote the y-intercept. Oh, okay, I did. Y-intercept here, -4. Slope is 1/12. All right. What should we do on this one? You want to keep the scale at 1, or what do you want to do?
2.
Go by 2s. Go by 2s on the x's and the y's? Okay. So we're going to go by 2s. All right, so all I have to do is just tell it. That's what I'm doing. I'm going by 2s. So what's the y-intercept?
-4.
Which means I'm going to go to there, right? Yep. Okay, so there's my y-intercept. What's the slope? 1/12. So I'm going to go up.
1.
I can go up 1, which would put me right there in the halfway point. And then how much over? 2, 4, 6, 8, 10, 12. So right about there. Again, this is a very, very flat line. All right, but the slope's 1/12, so it should be pretty darn flat. Okay. I could have went up 2 and over 24, but that would have been kind of a mess. But I could have did it. I think the point is to show you that you can make, is that sometimes you got to scale graphs a little differently. It's kind of nasty. Okay, let's see what this one is. Y equals -25 for x plus 25. Okay, y-intercept 25. Okay, here we go. So what should we go by on the
5s.
on which axis?
Y.
Okay, so it's going to be 5. Okay. All right, that's nice because that's going to be 1, 2, 3, 4, 5. There's my 25. What's my slope? 25 over 4. Okay, so what if we do this time? Why don't we just leave this at 1? Okay, so -25, 4. So that means I'm going to go down here. How much am I going to go down?
5.
Go down to 5. 1, 2, 3, 4, 5. Going to put me there. Over how much? 4, but I'm going by 1s. 1, 2, 3, 4. So that would be it. Like that. Okay, so we went down. We went up to 25. That's my y-int. Okay, slope is -25, so I went down because I'm going by 5s on the y, going by 1s on the x. So I just went over 4. Okay. Any questions on what they did there? It's just kind of weird looking equations. Okay. Number 2. This is on the next page, by the way. F equals 9/5 C plus 32. So it says a linear equation F equals 9/5 C plus 32. Models the temperature in degrees Fahrenheit given the temperature in degrees Celsius. Graph the equation, provide a coordinate plane. You will need to set up an appropriate scale on the coordinate plane for your graph to fit properly. Label C and F intercepts the equation of the line. Okay, here we go. We can do this. Okay, here it is. All right. So, where's the F? F is going to be X or Y axis. Which one?
Y.
Very good. F is there. C is down here. Okay, so I'm telling the person I'm graphing this for, here's where it is, but I guess it shows you in the book. Let's see. What is the y-intercept?
32.
32. Okay. Again, I can't fit 32 on there. What should we go by?
8.
8. Interesting.
Is that bad?
No, it's just interesting. I've never gone by 8s before.
You have to go 4.
You want to go by 4 instead? Or 8s?
8.
Okay, you guys pick 8s. We'll go with 8s. I've just never done it before. 8, 16, 24, 32. There it is. Okay? So my slope is 9/5. Oh, nice. You picked 8.
Whatever.
What do you want to go by on the...
1.
Okay, 1. All right. So now let's see. I have to do 9 over 5. Oof. So, let's see. If I went up 9... So if I go up 9 units here, it's going to be just a hair past that next one, right?
Yeah.
Okay, so a hair past that and over 5. 1, 2, 3, 4, 5. Good thing I don't have this to be a real accurate line.
Are we off by 8s though? Am I wrong? Did I say something wrong?
No, so if I go, but I have to go up 9, don't I?
Oh, okay, yeah, never mind.
And that's okay. Okay, so there it is. Let's see, what else does it say we have to do? We have to graph it. It fits properly. I label the C and F intercepts. Oh, nasty. Okay, well there is the F intercept is right there. Okay, now we'd have to find the other intercept way back here. What do we know about that intercept way back here?
Way back way.
What would be the y coordinate right there? No idea? 0. Yeah. Okay, so let's do this. Let's do it this way. Let's come down here and say, okay, if that's the case, I'm going to put 0 for F and figure out what C is. Because I don't want to extend the graph out because that's going to be too hard to figure. So I'm just going to do it this way. And I just need somebody to solve that equation right there and tell me what C is. And that will give me my C intercept. Anybody get it?
17.7.
So you took negative 32 and divided it by, what would you do to get that?
I have a really crappy calculator, but I did 9 divided by 5, and then 32 divided by whatever 9 divided by 5 was. So it's 32 divided by 1.8. And it's, yep.
Okay. There it is. That one's done. Okay, next one. Number 3. Then we're going to take a quick little break here. Alright, let's see what we got this time. Okay, it says you're leaving from Eugene for a Ducks from a Ducks game, driving back Portland. Eugene is about 104 miles. From Portland traffic, 104 miles. And the traffic keeps you driving at an average rate of 52. Model an equation which gives the distance DUR from home, T hours after leaving Eugene, then graph that equation in the provided coordinate plane. You'll need to set up an appropriate window, la-di-da. Okay, here we go. So, we're 104 miles away, right, in the beginning, correct? And we're going 52 miles per hour. And I'm going to write an equation that represents the distance I am to my house. Okay? So, anybody have any ideas on what that equation might look like?
B equals 52x, and then plus 104.
Yeah? Yeah. Y equals mx plus b is what we're looking at. Okay, m is the slope. Remember we talked about how that's a rate. There's your rate. So it'd be 52x plus 104. Okay, but since I'm not going away, in other words, I'm not adding miles, I'm subtracting, that's got to be a negative. Does that make sense?
What was that again?
This has to be a negative 52 because the D, it represents the distance to my house. So in the beginning, or your house, in the beginning we're 104 miles away, correct? After 1 hour, I'm going to take 52 and subtract 104 because I'm going to be 52 miles closer to getting home. Does that make sense? Okay, so that's why I have to make it a negative. If I make it a positive, then I'm going to be 156 miles away, which means I'm going to California. Okay. All right, so now we got our equation. Now we got to graph the darn thing. T down here, D is here. Okay, so let's see, y-intercept is 104. All right, so let's see. I think we'll go by, let's see if we go. I'm going to go by tens. That's going to put me right at 100 right there. Okay. And then I can go by ones here because I think that's best. All right. Okay, so what's the y-intercept?
104.
So I'm just a hair right above that. Okay. Slope is?
Negative 52.
Okay, so I'm going to drop down. Remember, I'm going by 90, going by tens. So I'm just going to start here. 1, 2, 3, 4, 5, and just a little extra right there. And then how much do I go over? 1.
So it'll take 2 hours.
Something like that, yep. Label the T, and yeah, so then it wants me to figure out this guy right here, that x-intercept. I know D is going to be 0 there. And just solve that out. is dose. There we are. All right. So, hey, we're done with that supplement. All right. Go take a little 5-minute break or so. We'll do the last supplement. And then we'll almost be done. This is plus 104 here. And then I subtracted 104 to move it over to this side and solved it out. Ooh, I gotta stop this. What's that? Okay, so what is the, let's do A. What is the y-intercept for A? 3, so I know that's 3. So now I have to find the slope, so I just got to pick a couple of points that I can work with. Like 3 is 1. What would be another point we could work with? What's another point that line goes through? 1, 1. Okay, because it looks like it's 1, 1 to me, but then, I don't know, I don't have my glasses. 1, 1's okay? Alright, so how are we going to find the slope? Rise and run, how much do we rise? We're rising from 1, 1 to 3. How much is that? 2. Okay. How much is the run from 1, 1 back to 3, 0, 3? 1, but it's negative, so that's how I would do that. Okay. Done. Y equals negative 2x plus 3. A is done. Alright, so I'm just picking points right in the equation. Notice I'm using this form rather than the other one because the other one would be pretty long to do. Okay, let's do the same thing. Y equals, what is the y-intercept for, can we figure out, B. What is the y-intercept for B? Negative 2 plus, okay, what's another point we could use on there to help us? 3, negative 1. Yeah, I agree with that. So how much do we need to rise to get from negative 2 to 3, negative 1? How much are we going to go up there? 1. And we're going to run 3. So there's my slope. Notice it's positive because that's the way the line's flowing. Okay, so there's that one. C. Okay, so what's the y-intercept for B? For C, sorry. Y-intercept, do we know it? You can't tell, right? Can't really tell it. Okay. Well, let's find some points then. Do we have any points we can use on that line?
9 and 3? Or 3 and 9? I don't know. No, that doesn't make sense.
What about, is 6, negative 10 1?
No.
It's just a hair below it?
Yeah.
Well, this is 3 and 0. Okay, that'll work. 3 and 0. Man, we just need one more if we can find one more. What about negative 10 and 30? Is that one? You see what I'm talking about? It looks like it is. Negative 10 and 30?
For C? No.
Yeah.
You can use 7, negative 10.
7 and negative 10?
Yeah.
Okay. All right. Okay, so let's find the slope then. What's our slope going to be? Yeah, so it'd be negative 10 minus 0 over 7 minus 3. So negative 10 over 4. So there's my slope. Now I have to do is find the y-intercept. How do I find the y-intercept? Pick a point. What if we put 3 here? Put 0 there. 0 equals, see, negative 10. This would be negative 30 over 4. So b is going to equal 30 over 4. So there's my equation. Negative 10 fourths x plus 30 over 4. Okay. What a mess that is. Okay.
Are we doing the entire supplement?
Well, I'm not going to do D because that's a mess.
I mean, all of them then?
We'll do a good portion of them, but I don't think we need to do all of them. There's quite a few. It's kind of hefty. E, let's do that one because that one's going to be a little bit easier to do. All right, what about the y-intercept? Can we estimate what that is? I think we can get that one. What's the y-intercept? 7. Okay, good. What's another point that line goes through? It's going to help us find a slope. Ooh, there's a point I see it goes through. What's another point that it goes through? 20 and 4. Okay, so 20 and 4 and 0 and 7. Those are my 2 points I'm going to use. So let's find the slope. Okay, so there's my slope. Now I can fill in with my answer. There's E. Okay, so all I'm doing is just kind of picking points there that I can work with, right? So I can find that equation. F is another one. We can work with F. Okay, so what's the y-intercept for F? 0. Good deal. Okay, so 0 is 1, 0, 0 is 1 point. I need to find another point so I can find my slope. Anybody see another one we can work with? Yeah, 20 and 7 is a good one. That's what you meant, right? Okay, so then change here is going to be 7. Change there is going to be 20. So there's my slope. I don't have to worry about the 0 because just 0. Done with that one.